calipers and vernier calipers. In this module you'll learn about calipers, vernier calipers. Using vernier calipers, some objects may be round. How do we measure such objects? With a meter rule and an instrument called caliper. There are two types of calipers, external and internal. External calipers are used to measure the outside diameter or outer width of an object. Shown here is an external caliper. Let's check out how to use it to measure the outer surface of a pipe. Move the jaws of the caliper so that they touch the outer surface of the pipe. Then measure the distance between the jaws with a meter rule. Pretty easy, wasn't it? Contrary to external calipers, internal calipers are used to measure inside diameter or internal width of an object. Shown here is an internal caliper. Let's use it to measure the inner width of the pipe. The steps are the same as we followed earlier, only that in this case we'll measure the internal width. So move the jaws so that they touch the inner surface of the pipe. And lastly, measure the distance between the jaws with a meter rule. Vernier calipers are used to measure internal and external lengths very accurately. They are very accurate to 0.1 millimeter or 0.01 centimeter compared to only 0.1 centimeter for a meter rule. A vernier caliper consists of a main scale engraved on a fixed ruler and an auxiliary vernier scale engraved on a movable jaw. The main scale is calibrated in centimeters with the smallest division in millimeters and has divisions of 1 millimeter, while the vernier scale has divisions of 0.9 millimeter. The movable vernier scale is free to slide along the length of the fixed ruler. The vernier scale has 10 divisions that cover the same distance as 9 divisions on the main scale. Therefore, the length of the vernier scale is 9.0 millimeters. This graduation guarantees that one of the vernier markings will line up exactly with the mark on the main scale. The outside jaws are used to close around the outside of an object and are used to measure the outside dimension. The inside jaws, on the other hand, fit into the empty space or hole of an object and measure the inside dimension. The screw helps the jaws to close tightly. Here is a diagram showing all parts of a vernier caliper. Take a look at all its parts: the main scale, the vernier scale, inside jaw, outside jaw, screw and tail. For using vernier calipers, we follow certain steps. First, we close the jaws and check that the zero on the main scale and the zero on the vernier scale are together. If they're not in line, then there is a zero error. The second step is to open the jaws wide enough to hold an object. You can do this by sliding the vernier scale. The third step is to check the reading. Reading is done in two steps. One from the main scale and other from the vernier scale. Length is checked by reading the main scale mark that coincides with and falls just before or opposite to the zero reading on the vernier scale. For example, the main scale reading shown here is 4.8. Vernier reading is done by checking the mark that best coincides with the main scale line. For example, the vernier scale shown here reads 3. This is equivalent to 0.03 centimeters. The actual reading or the length of an object would be the sum of the main scale reading and the vernier scale reading. Thus the length of the object shown here is 4.8 plus 0.03, which equals 4.83 centimeters. If the jaws are closed but the zero marks on the main scale and the vernier scale are not together, there is an error known as the zero error. If the zero on the vernier scale is to the right of the main scale, then the error is said to be positive zero error. So the zero correction should be subtracted from the reading which is measured. This is because a vernier caliper with positive error is actually measuring more than the actual length. If the zero on the vernier scale is to the left of the main scale, then the error is said to be negative zero error. So the zero correction should be added from the reading which is measured. This is because a vernier caliper with negative error is actually measuring less than the actual length. In the visual, the third line after zero on the vernier scale coincides with the line on the main scale.
In this module, you have learned the following.
Round objects measures with a meter rule and an instrument called caliper. Vernier calipers are used to measure internal and external lengths very accurately. If the zero marks on the main scale and the vernier scale are not together, there is an error known as the zero error. If the zero on the vernier scale is to the right of the main scale, then the error is said to be positive zero error. If the zero on the vernier scale is to the left of the main scale, then the error is said to be negative zero error.